Hi, everybody. I wanted to just do one problem, one of the exercises in 1.9. So I'm gonna cut out the video because the blah blah. You know the drill by now. So let's just go to it. Okay, so this is section 1.9. This is problem number 4. If the sum of two irreducible fractions is an integer, the denominators of the fraction are equal. Now, irreducible means that it's in lowest terms, means that the numerator and the denominator have a greatest common factor of 1. That's just explaining that terminology. So let's go see how that's done. So here we are in my trusty Google Docs and 1.9 exercise number 4. So I want to show the sum of two irreducible fractions is an integer, the denominators are equal. Okay, so here's my two fractions, a over b and plus m over n, and that equals some integer k. So just to be clear, the greatest common factor of a and b is 1, and the greatest common factor of m and n is 1. That's just to be clear. That's what it means to be irreducible. Anyway, I'm going to take this first equation here, and I'm going to multiply it by bn. So I get here an plus bm equals kbn. All I did is I just took this top equation here and I just multiplied it through to get rid of the fractions. Now, from this second equation here, I'm actually highlighting it, and I didn't really need to make all these different equations, but I think it's to me it's just easier if you have it that way. I solve for an by bringing the bm to the other side, so an is equal to b times kn minus m, and I don't care what that is; it's just some number. And bm going back to that same equation, solving for bm, I get bm is equal to n times kb minus a, which again I don't care about. I don't care what's inside the parentheses. What I really care is, let's look at these two equations here. So in this equation, let me call it, I should really label these equations so you know what I'm talking about. Let's call this equation one, and we'll call this. I keep saying this equation, that equation. Let me. Okay, so in equation 2, we see that the product of an is equal to b times something else. So obviously, b obviously divides the right hand side. So b divides. Let me write it this way: b. Oops. Only b divides an, hence b divides n. And let me make. I want to make this nice and purple and just like the other one. Let's make it. Okay, let's make it. I like purple. It's a nice color. So since now b divides a, because b divides the right hand side of the equation, so it divides the left hand side. Now, since a and b are relatively prime, if b divides an, that means that b has to divide n itself, because it doesn't because a doesn't have any common factors with b. They call this Gauss's lemma or something like that. Anyway, or something like that. And here I have the same thing. N divides bm. Hence, I'm just again, I just want to make this a little more clear. Let's make it purple, which is always nicer. Okay. So n has to divide b. Well, look at this. B divides n divides b. The only way that's possible, the only way b can divide n and n can divide b. Oops, how'd that happen? Is if n equals b, which is exactly what we're trying to prove. which means that the two, which means that the two denominators are equal. Oh, I should learn how to spell. There you go. Are equal. And I guess I'm just going to write QED because that's always fun. And there you go. All right, everybody. That's it for this video. See you guys next time. Bye. How do I stop this? Oh, there you go. Stop recording.